Hey, you guys. I've decided to start to do these videos in case kids are absent. And so this is my first one. And actually, I'm going to go back and do other ones because I know it's a struggle right now if you're absent and stuff to just watch a presentation, slideshow, and stuff like that. So I will go ahead and kind of just present the information, make it pretty straightforward, maybe explain a little bit what we did in class and point out where you can access all that material for the next I don't know, at least this unit and stuff. So you're going to get tired of seeing my ugly mug, I guess, if you've been absent a lot and stuff, but you'll get used to it. I know I'd look a little bit different without a mask on. I don't even have a mask around here, but, and when you get tired of the video, the nice thing is you can just pause it, get rid of me for 15, 20 minutes, and then come back. So I'll go ahead and get to the PowerPoint, and then we'll go ahead and get started here, you guys. Let's see here. And I think I'm going to make myself a little bit smaller. There we are. I can go a little bit. Well, no, I'll go smaller. So I warn you too, I'm only doing one take with this because, you know, I don't want to have to redo it over and over again. So if I mess up, if I stutter, you're going to have to deal with it. So first of all, make sure that you've turned in the labs, gas content, soap activity, and the viscosity labs. I'm going to be grading this weekend, but that's obviously come and gone. So homework was volcanic hazards, and it was in Google Classroom. It was all completed in Google Classroom. So make sure that that is turned into Google Classroom. So we're going to do the little Pacific Northwest volcano activity. That's what I'm going to present to you. And then you're going to be doing in class. They did a chocolate viscosity lab. So in terms of that, I will put that in Google Classroom with little videos of me. So you can actually watch little videos of me. Homework is study for vocab check. Okay, and then the other thing is there's a viscosity practice problem. Obviously, I think you guys are figuring out, or you should be figuring out by now, that the lab portion of the next test will be viscosity problem. And so I'm trying to give you lots of practice with that, you guys. And so you know how to do it. You've already done once or three times in lab. You'll get another opportunity to practice again today, and then there's homework to practice. So let's get on with the presentation in terms of what's happening here in the Pacific Northwest. So I call this past, present, and future. What's happening here in basically Oregon, Washington, California area and stuff like that. Okay. First, will we have any warning? And the answer is yes, you guys. We've kind of gone over this over and over again, but I want to remind you the number one warning signal that we'll have is there'll be some earthquake activity. Generally, right before we see an eruption, you see the amount of earthquakes. They're not big earthquakes. It's just the magma moving up through the rock and stuff. But we see the number of earthquakes dramatically increase. Okay, during the last big eruption right before with Mount St. Helens, they were 1 to 4 every minute. Okay, so we're talking 15, 20, 30 seconds apart. Most of them you wouldn't be able to feel, but they'd definitely be there. Increased Gauss amounts, mostly they're going to be measuring CO2, carbon dioxide, and sulfur dioxide, or just sulfur. Okay, we might see some deformation. In other words, the mountain might change a little bit of shape. And then the other thing is there's possibility that we'd see increased snow melt because of the fact that you've got glaciers, and especially in the wintertime, then that heat from the magma coming up would obviously melt that. Okay, so this first little picture here, this first image, is just one to show you the different peaks in the Cascade Volcanic Arc that are kind of the big ones, okay? I actually have this picture on a shirt. I sometimes wear it, but then people make fun of me, which isn't isn't atypical by any means. But what it's showing you, first of all, is this red line right over here. I think you can see my cursor. This red line right over here indicates that volcanoes that have erupted in the last 200 years. Okay, so that makes them fairly active. Now, reality is scientists consider 4,000 years as still active. Okay, so you look at these, the ones that have low volcanoes, that means they're active. And so you look, I mean, the one that jumps out to me is what is the volcano that's erupted most in the last 4,000 years, and it stands out fairly obvious as Mount St. Helens. The other things that jump out to me, I like to look at Mount Hood because that's the one we go skiing at. That's the one that probably most of you guys visit, maybe in the summer for hikes or camping. And you'll notice that Mount Hood has erupted way back, almost 2,000 years, but it has erupted in the last 200 years, okay? And it basically erupted, I like to think of it, they erupted right before Lewis and Clark got here, or a few years prior to them getting here, so in the early 1800s, okay? The other one that I like to kind of point out is Crater Lake. Notice Crater Lake hasn't erupted in the last 4,000 years. It erupted about 7,600 years ago. But the point is, there's quite a few active volcanoes in this area, okay, or in this region, but also a lot within that 200-year period that really make them active, okay? Okay, so what I want to do is I want to look, first of all, and just do a general overview of the active volcanoes here in the Pacific Northwest. So the ones that erupted in the last 200 years. Mount St. Helens is obviously currently active, most active over the last 4,000 years. Mount Hood, like I said, erupted 1780s, 1810, probably somewhere, I would actually say, guess more in the early 1800s. Mount Rainier erupted in the 1840s, so it erupted relatively. It wasn't a big eruption. It was more just like a little steam event and let off a little bit of maybe lava and stuff. And then last eruption, big eruption, was about 1,000 years ago. And then Mount Baker and Glacier Peak, which are both in northern Washington, erupted in the last 200 years. And then south of us in California, Mount Shasta and Mount Lassen have both erupted in the last 200 years. Okay, so Mount St. Helens. Let's talk Mount St. Helens first. That's the one that, in terms of people know the best. I mean, it's probably the most famous of any volcano. Maybe, I don't know if you can say the world, but at least in the United States here. And so it just sits a little bit northeast of us. It's currently active, 2004 to current, and it's the most active, obviously, of any volcano in the Cascade Range. The last major eruption, so the one that people always talk about, the one that we like see, hear about, and, people remember as the eruption of Mount St. Helens, happened in 1980, in May of 1980. It really wasn't that big of an eruption, historically speaking, like if you look like all over the world and for hundreds of years, but it was significant because it was the first continental eruption in the United States since 1914, okay? And scientists swarmed here. You guys, it was crazy around here in terms of scientists. They wanted to see the eruption. They wanted to see the aftermath of the eruption. In other words, what, how the area was going to come back in terms of ecologically speaking, what damage, there were deaths. It was a big deal, you guys. So from 1980, after its eruption, for about 6 years after that, until 1986, it continued to erupt and create a lava dome. And so you can kind of see this little lava dome right here in the center, okay? It created that lava dome and built that up, okay, over a 6-year period. And then in 1986, everything kind of shut down, okay? It just kind of went completely dormant. I don't want to use the word dormant, but it just kind of, nothing was going on up there until 2004, when we had a small ash event or steam event that happened on the, it was actually in the afternoon, because I was driving home from school. I was just crossing the Selwood Bridge. I live over in Selwood. I looked up and it was like, oh, that's a weird cloud, because there's a clear day right over Mount St. Helens. And that was an ash event that happened in 2004. And then it continued to erupt. And it's still, once in a while, gives off a little ash. It's definitely warm up there. And the lava dome is currently building, although not as quick as a rate as 2004. It kind of slowed down a little bit in 2006. Okay. So what did Mount St. Helens look like before the eruption? This is before the 1980 eruption. It was a mountain. I mean, I almost think it looks most similar. If you go skiing on Mount Bachelor, I feel like that's the one it looks most similar to. It was a mountain, a big mountain. And what you have to kind of envision is, you look at this picture now of what it looks like now, and we've lost about a third of the mountain almost during the eruption. These are my kids when they were a lot younger. They'd probably kill me if they know that I was putting them on this PowerPoint. But this was about 5 or 6 years ago. We went up there just on a hike and stuff. And you can see the eruption, basically removed this 1/3 of the top of the mountain. And you can see the lava dome right in here, right over my bald head. Or I actually had a little bit more hair back then, but okay, right over my head there, you can see the lava dome that was created. And people always ask, they're like, well, where did all that mountain go? Like, where did it disappear to? The reality is the mountain went right here. Okay. This was the ash fallout from the 1980 eruption. And you can see like the ash spread over a good portion of the United States. And that was ash that not only came out of the magma chamber, but also part of the mountain itself, all the rock that made up that mountain, that third of the mountain that was blown away, that ends up being spread across the United States. I always get a quick question, okay, if you are, during class, about this little spot right here in basically Oklahoma, Kansas area. They think that was because maybe the ash came over the Rocky Mountains and kind of stayed up high, and then that's where it kind of settled down in there. But it's kind of a weird, like, little target right there where there was a considerable amount of ash that happened after that 1980 eruption, okay? So the other question a lot of times I get is, Why did it all go from west to east? And that's because the prevailing winds, the winds that normally blow in the United States, start in the west and head towards the east. And so, you look at Mount St. Helens right here, we don't get as much ash here because we sit to the west of Mount St. Helens. And so, unless the wind was blowing kind of funky that day, normally the wind blows from west to east. And so it takes most of that ash and most of that, pyroclast, that tephra, and moves it out towards the east, okay, towards kind of the Montana area and the Idaho area and the Wyoming area, and the Dakota areas, okay. These pictures that I have right here, these are some pictures that I actually had a friend that worked for the USGS. He took a bunch of these. He was setting up this seismic equipment and some of the gas monitoring materials right inside the crater right after it erupted in 2004. And so these are some pictures. So you can see how thick the magma is. This is actually the vent right there. You can see steam coming from it and stuff. This is very, very, very thick magma. This is called the whale's back. It was a big just piece of magma that just basically came out of the earth and kind of thrust up there. But you can see it's not like Pahoehoe lava or not like A'a lava. This is thick, chunky lava that really doesn't flow, okay? It just builds up that lava dome idea. Okay, there we are. This is back on that hike, you guys. That's one of the equipment or pieces of equipment that measures gas and also measures seismic any activity. And that's quite a ways away from Mount St. Helens. You can see here, but it'd still be able to pick up the seismic activity and if there was an increased amount of gas. And then it's broadcasted out and it's picked up by a satellite, and the scientists can use that information. This is one that he put right inside the crater, so you can see the dome right here. This is the big dome right here, and this is the equipment and stuff. So that was just kind of a picture that he took for me. You can see the steam. It's still warm up there. Okay, you can see the steam coming off right here. Okay, that's looking down inside of the crater. That's a little bit of a view. This is after the 2004 eruption. You can see the ash right over here on the edge of the mountain right here, and you can kind of see the steam and ash that kind of is sneaking over the edge. So it wasn't a huge event, but it was definitely an event that, we took note of when it did happen. There's another lava dome. This lava dome was unique because he took a picture of it because that one actually destroyed one of his measuring devices, one of his seismic measuring devices. He went up there, deposited what he thought was far enough away from the main dome, and then this little dome popped up and actually destroyed it. So this picture was taken in 2008. So it was about 3 or 4 years after he actually put the equipment in there. There's a picture from the air. I don't know if I took this picture, if he took this picture, but I really like this picture because it's winter. And so you can see it's snow covered. That's what it looked like right now up there. But you can see that the magma and stuff is warm enough down here that it's melting that snow. And it's not, it's not able to build up. The snow is not able to build up there. It's just a melting because of the warmth and stuff generated by the magma that's so close to the surface. Okay, let's move on to Mount Hood. I actually like to spend more of my time on Mount Hood, to be honest, you guys, in terms of like I want you guys to know, because of the fact that Mount Hood is kind of where you guys spend a lot of your time. Like if you're going to go skiing, you guys go to Mount Hood a lot. If you guys go camping or if you guys go to hiking or something in the summertime, a lot of you guys are doing that on Mount Hood. So Mount Hood last erupted, I like to say 1805. It could be a little bit earlier than that, but it's probably somewhere right about in there. The reason we know that is because when Lewis and Clark came and discovered this area, or not discovered it, but explored this area, they mentioned a lot about the fact that a lot of the area was covered by ash and the streams were choked with ash, and they called them, they were the Sandy River and stuff, because although I think he had another name for it back, maybe the Muddy River or something, and that was because it was choked full of ash from the last eruption. So what happened? Was it a big tephra, event where, like Mount St. Helens where it blew into the air? No. Did it have lava flows that came down the side of the mountain, like Hawaii or maybe some of the Icelandic volcanoes? No. Primarily what happens with Mount Hood, it's the growth and collapse of a lava dome. So basically the lava builds up really, really thick, viscous lava. We know what viscosity means. It builds up this thick viscosity lava, builds. And when it gets oversteepened, what happens? It falls and cascades down the side of it and creates, hopefully you know what they're called. I'll leave a little pyroclastic flows. You should know what those are by now. So those flows of hot ash, dust, rock that's going to go sweeping down the sides of the mountains very fast, obliterate everything in its way, cook anything that's in its way, basically destroy, create a path of destruction down the side of the mountain. Okay. Now, in terms of what they think is going to happen in the future, what's the most likely scenario? Once again, it's going to be a growth and a collapse of a lava dome near a place called Crater Rock, which I'll show you in just a minute. You people that ski, you guys, that go up there a little bit, it's right above Palmer Ski Lift, okay? It's that big pinnacle. I'll wait, and I'll show you a picture in just a minute, okay? But that's the lava dome, and that's going to build and build and build, and it's going to get oversteepened, and then we're going to send pyroclastic flows down the side of the mountain, and those are also going to probably generate lahars, okay? So that's kind of what happens on Mount Hood, you guys. And this picture was taken just Timberline would be right about over here if you go to Timberline Lodge. So it's looking directly up at the mountain, like if you were looking up from Timberline. This rock right here is called Crater Rock, okay? It's a little pinnacle that sticks out there. When you climb Mount Hood, you go right by it usually, okay? Palmer Ski Lift sits up here, and basically it's this pinnacle that sits up there, and it still steams, you guys. There's gas vents up there and everything, okay? And that's referred to as Crater Rock. That's where they think it's going to happen, okay? And then it builds up, and then it sends pyroclastic flows down the mountain. And so you look at this, all this material down here below Crater Rock, that's all just pyroclastic flow over years and years and centuries and, thousands of years that Mount Hood has erupted the same exact way by the growth and collapse of a lava dome from Crater Rock. The other side of the mountain is pretty undisturbed. I'll show you a picture of that in just a minute, okay? But if you look at it, okay, here's Mount Hood, here's Crater Rock right here at the top, and then here's Timberline Lodge, so on and so forth, okay, going down. I like to show this, and I'll come back to that map in just a minute. But you look at this and the kind of the history of how it's erupted the last 30,000 years, and you see here, lava dome at Crater Rock, pyroclastic flow. 1,500 years ago, lava dome at Crater Rock, pyroclastic flows. That sequence that's just happened over and over again. And if you look at the different sides of the mountains, it becomes really obvious, okay? We've got the south flank, which is the one that you've got the ski slopes on, like Timberline, like Mount Hood Meadows, so on and so forth. And you can see there's Crater Rock, and then this big flat, basically almost like an avalanche, okay, of material that has just been created by pyroclastic flow after pyroclastic flow after pyroclastic flow. So almost like an apron or just a nice kind of flat. It's not flat, it's still steep, you guys, but it's this big area that just kind of extends out from the mountain. You go to the north side, like if you were looking at it from Hood River, and the mountain looks completely different, you guys. It's rugged. I mean, there's no pyroclastic flow evidence there, you guys. And that's because basically it doesn't really get touched by these pyroclastic flows. Instead, what's happened is it erupted and built up, and now it's been eroded by glaciers over ice ages and stuff like that. And so we end up with this extremely rugged north face of the mountain, whereas the south face is relatively flat because of those pyroclastic flows that have swept out. Okay. So let me go back to this one really quick here. I wanted to show you this. So people always ask about and this is hard because people always say, well, what would happen if I was at Timberline? Well, the reality is this, you guys, you wouldn't be at Timberline if the mountain was considering, if it might erupt. They would have evacuated the mountain way in advance. But let's just hypothetically say, okay, we're at Timberline. If you look at this little map here that's been created, you can see here, Timberline, pyroclastic flow, boom, gone. Probably if you're at Timberline, you got between 10, 15 seconds, and then boom, Timberline Lodge is gone. And if you're there, you're obliterated. I mean, everything gets destroyed in its path. Same thing with government camp. Maybe you got 10 more seconds, 15 more seconds if you're at government camp, but it also is going to get hit with the pyroclastic flow. But then you look here at Ski Bowl right here, and Ski Bowl sits on the other side of the road. There's a very good chance that Ski Bowl would not be necessarily hit by the pyroclastic flow. And you look at like Meadows over here. Meadows would get hit by the ash cloud and ballistics, probably some lapilli, some of those cinders and stuff, but probably not be hit by the pyroclastic flow, okay? And then you look at the north side of the mountain, and there's no hazard over here. I mean, there are hazards. I'm sure it's going to have some ash that comes raining down and stuff, but the reality is about 90 to 95%, positivity rate that they think that the eruption is going to happen from Crater Rock right here. And so you kind of look at that map and you're like, wow, that's a little bit, it's strange that only one side of the mountain is kind of pointed out, okay, as being, as having a big hazard. Um, let's look at this map really quick here. Now, this is another inundation map. This is not pyroclastic flows. This is not, you know, TEF or anything like that. It's something else. And you should be able to pick up on this. You probably won't, I'm not, you know, in terms of right off the bat. But if you notice, these are river valleys. So the things that go down river valleys that we talked about, volcanic hazards, we talk about lahars. So this is a lahar map. And so all these areas are in danger of having lahar. And so you look like these towns, as you're going up Highway 26, like the towns of Wildwood, Welches, Wemy, okay, Rhododendron, those towns right in there. You got about 30 minutes after the mountain erupts before you hit with a lahar. Hood River has about an hour before it gets hit with a lahar. You got like, let's go all the way down to Troutdale, which is way out kind of towards Gresham. You got about 3.5 hours. So the idea is this: the lahars are very dangerous because of the fact that they aren't necessarily right near the mountain, right? I mean, they are right near the mountain, but they can also go miles, 10s, 20s, 30 miles downstream. I also like to point out to kids right here, this is Highway 26. So here you see Sandy right here. Here's Highway 26. Literally, the lahar deposits go right over the top of that. Or you could actually say that Highway 26 were built on past lahar deposits. And people always say, well, why would they build a highway on lahar deposits? That seems just stupid. But the reality is the lahar deposits sit in bottom of valleys. That's where we build roads because it's flat and because you can build a road fairly easy there. Okay. And so, you know, I always tell kids, like, one of the first things you want to do is if you were up, let's say, in one of these places like Wildwood, Wemy, or Welches, to be honest, you probably wouldn't have been evacuated from there if Mount Hood was threatening to erupt. But the idea is, terrible thing to do is to try to get in your car, because if you've ever been up to Mount Hood on a Sunday afternoon on the ski weekend, what happens? You're in a traffic jam for hours upon hours upon hours. And so everybody's getting off, trying to get off the mountain in the same time. If there's a volcanic eruption, it's basically Highway 26 is going to be a parking lot. Okay. There's going to be very little car movement. And as a result, you probably don't want to jump in your car. The secret is to just get up above the bottom of the valley so you don't get hit by those mud flows, the debris flows that we call lahars. Okay. So to kind of summarize, and you can put this on your notes, this is on the back page here. I like to kind of summarize and just think, what's going to happen? Growth and collapse of lava dome, but the big thing is pyroclastic flows down from crater rock. Timberline, probably gone. Government camp, gone. 15, 20, maybe 10 to 30 seconds, and those places are going to be obliterated, okay, from the pyroclastic flow. Not a great thought to think of, but that's reality. Then the lahars are going to come down, and they can go on all the valleys all the way to the Columbia River, you guys. Highway 26, like I said before, built right on the lahar deposit, so it's going to follow much of Highway 26 as it kind of sneaks past those rivers and stuff. The Sandy River is going to get full. All these rivers, the Salmon River that are located in and around Mount Hood, okay? So just kind of be aware. They're going to have pyroclastic flows, and you're going to have lahars. I'll repeat once again, probably not lava flows, probably not Tefra going up into the air. There's I've read, and I don't want to quote this, but it's about 90 to 95% chance that it's going to be the growth and collapse of a lava dome from crater rock. It's just, that's where scientists think it's going to happen. Okay. So jump ahead a little bit here. Next mountain I want to talk about, and I kind of tried to summarize these a little bit down at the bottom of our page, but Mount Rainier. Mount Rainier is the mountain up by Seattle. What do I have to say about Mount Rainier? It's probably considered the most dangerous of any of the volcanoes in the Cascades. And it's not because it's necessarily bigger. It's not because it's going to blow bigger or there's going to be more chance that it's going to erupt or anything like that. The main reason it's considered the most dangerous is because it has a huge volume of ice and snow on it. Okay. And when that melts, especially if it happened in the wintertime, it's going to generate a huge amount of lahars. And the biggest issue is this: we have really built up around the base of Mount Rainier, especially in the river valleys that surround Mount Rainier. Many of the suburbs of Seattle and of Tacoma sit on lahar deposits in the valleys that surround Mount Rainier. Okay, and so we have a large population base, and that's why they consider it to be probably the most dangerous. Okay. In terms of when it last erupted, as I mentioned earlier, it erupted in the 1840s. Probably not, it wasn't a large eruption. They talked about it. It was mentioned in newspapers and stuff like that. The old newspapers and stuff, you can find mention of it. big eruption about 1,000 years ago. Okay, Mount Rainier is a pretty big mountain. If you haven't been to Mount Rainier, you guys, it's a national park. I think it was commissioned in 1899. It's one of the older national parks. Yellowstone is the oldest national park. Okay, Mount Rainier is where it's amazing to go there, you guys. The mountain is huge. I mean, Mount Hood is big, right? We always think of Mount Hood as being big. You got about 3,000 more feet, I believe, with Mount Rainier. Okay, so it's a big mountain. It's pretty cool. And like I mentioned, it can be dangerous because it has a lot more glaciers, which I think it makes it a little bit neater when you go up to visit it. You see all these like rich blue glaciers and stuff like that. So there's a map of lahar deposits. So you can see here's Mount Rainier, but then in all these river valleys that surround it, you're going to have these lahar deposits that have formed. Okay. And they look at all these rivers and stuff are going to fill up with lahar deposits. And that's the big risk associated with Mount Rainier. Okay, other mountains that you guys might be familiar with. The Three Sisters area. We got South Sister, we got North Sister, and we got Middle Sister. This is over by Black Butte. If you go over to Bend, you see these. South Sister was the last to erupt about 2,000 years ago, so it's been a long time. These are not what we necessarily consider to be the most active. However, I would like to mention that about 10 years ago, right down here at the base of South Sisters, it actually started to bulge. And it was bulging by about 3 centimeters a year. So not that much, you guys. I mean, this is not a huge amount. But it was enough that scientists were freaking out. I mean, they were just like, oh my God, there's going to be an eruption and it's going to be a lava flow. And so you're going to be able to sit at Black Butte and watch a lava flow kind of coming down the base of Mount Sister or South Sister. It's going to be awesome and stuff. And I still remember interviewing one of the scientists. He's like, I guarantee in the next 30 years, there'll be an eruptive and stuff. And then it stopped. About 10 or 15 years ago, it just stopped bulging. And it no longer is really active over there and stuff. The magma probably came up and kind of cooled right at the bottom. Okay. Mount Jefferson, Mount Washington, you also see those in Central Oregon, haven't erupted for a long period of time, but are still considered fairly active. They're not active, but they're still considered active, but they haven't erupted for a long period of time. Mount Bachelor erupted about 8 to 10,000 years ago. It poses little threat to becoming active in the future. You guys go skiing there and stuff in the wintertime and stuff. I love the kind of the look of Mount Bachelor. It's kind of your classic composite volcano. But once again, it poses little threat to being active in the future. Crater Lake. What you have to envision here is there was once a mountain called Mount Mazama that was roughly 12,000 feet tall. And it experienced a very, very large eruption about 7,700 years ago. What you have to kind of keep in mind is it basically blew the top off the top of the mountain. I mean, you talk about Mount St. Helens losing its top. This one lost 2/3 of its size, okay? And then as we've talked about, it created a caldera where the crater collapsed in on itself and then filled with water and created this beautiful lake. And we now have it as our Oregon's only national park. Do we think it's going to erupt anytime in the future? No. It's one of those volcanoes that we think is probably pretty inactive and probably won't erupt anytime in the near future, if ever again. I also like to point out here, right, the Wizard Island in the center, a little cinder cone that popped up on the bottom of the caldera after it cooled. And like I said, it's volcanic, it's not going to be active anytime soon. If you haven't been to Crater Lake, it's one of those things that you should go visit. I know I've talked about this and I know I've pushed this before, but it's one of those places in Oregon, in the Pacific Northwest, in the world that is just kind of this amazing feature, you guys. The water is so clear. It's cold, but you can jump into it if you hike down. There's one trail that goes down to it. It's still very, very pristine. So it's pretty sweet, you guys. I would highly recommend, if you haven't had a chance to get there, that you convince your parents to take you there. It's a long day trip. I'd recommend spending the night, but it is amazing, especially in the summertime. Okay. The last volcano that I kind of want to mention, and then I'll mention one other thing that happened here, was called the Newberry Caldera. And the Newberry Caldera is, if you've been to Bend, or Bend to Sun River, it's about 20 miles south of Bend Sun River. And it's funny because it's a national monument, but a lot of people have been there, but you don't even realize you're on a volcano. It's so big. It's got 2 lakes in the Sun River. Okay, right here, Paulina Lake and East Lake. And you can see this is a small little cinder cone. Right over here is what's called Big Obsidian Flow. So there's a huge obsidian flow that you can go and visit and hike through, where you're just walking in these huge chunks of obsidian. But it's a gigantic I mean, I guess you could say it's a caldera that's collapsed in itself, but it's a huge, and you can see there's a lava flow back here. But like I said, most people don't even know they've been there. I mean, I quizzed the classes and stuff, and there was a couple people in each class that kind of remember, oh yeah, I've been to those lakes. Can you go fishing there? Oh yeah, the fishing's really good and stuff like that. But they don't even realize that it's actually a volcano. Really, it's that big. When we're starting to talk 40 or 50 miles across. Okay. Okay. Last thing I got to mention is this. Columbia River basalts. Okay, so what happened here is this. You guys kind of remember we talked about flood basalts. It's when the land kind of opens up at a divergent boundary and lava spills out. So over right here at the border of kind of Idaho and Oregon, there was once a divergent boundary, or at least some fissures in the ground that basically opened up and spilled out basaltic lava that flowed over this entire region all the way down and even covered Portland. Went down through the Columbia River Gorge. These pictures right here are from the Columbia River Gorge, and you can see the different layers, okay? And there are these huge individual lava flows, basalt lava flows, okay? And then you can see right here, these, and they came all the way down, all the way to the oceans, and they are, you know, these are in the Columbia River Gorge right here, and you can see these different layers right here. Okay, they flowed slow, only about 3 miles per hour, but they were up to 3 stories high and flowed numerous times over this area. If you go out to the coast, you can see where they came and hit the ocean eventually, and these are these points of land, these headlands that stick out into the ocean, and those are all a function of these Columbia River basalts. Okay, so you can kind of look here. This is a pretty good picture of it. Here's where it opened up, and then the lava just spilled out over all these areas. Okay, some of it went this direction. We had some that went this direction, but you can see this area was covered a lot by these basalt mats, basically, as I like to think of them. Okay, so that is kind of it, you guys. The only other thing I want to say is this. So if you were absent, is let me make my face bigger. How do I? Oh, there it is. Then you have to put up with my ugly mug a little bit more. There it is. The other thing is your vocab sheet. I want you to take out your vocab sheet if you've got it, okay? And there's a couple words that I'm going to take off so that you don't have to study them, okay? Because we've got our vocab check next time. And so I'll read through this. Remember, you can always pause the video and come back to this. I'll also post these on Google Classroom, the words that I've taken off, okay? So looking down through the list, I'm not going to put Pacific Ring of Fire, okay? So you can mark that one off. I am not going to cover, let's see here, conduit, which is on the back side. You can cross that one off. I'm not going to put vent on. I just think that's just where the volcano material comes out of. That seems a little bit too easy. I will not cover volcanic neck. I will not cover sill, dike, plutons, laccolith, or batholith. Okay, but the last one, flood basalt, you should be aware of, okay? So I'll repeat them one more time in case you didn't have your vocab sheet out. Remember, you can always pause the video, you guys, too. Pacific Ring of Fire, cross that one out. Conduit, vent, volcanic neck, sill, dike, plutons, laccolith, and batholith. Okay, so I hope this helped you guys out. If you need to view other videos, I'm going to try to do some other videos over the next couple days, even of past lessons, because I know it's much easier. Although you got to look at my ugly face, I know that's, you know. But I can't make, I don't make many jokes and stuff like I do in, well, I try to make some jokes in class. You guys never laugh. But you guys, good luck. Contact me via email if you have any questions over anything, you guys. And I will try to put the note sheets also in Google Classroom so you can print those out. Okay, now I got to figure out how to shut this off.